Good afternoon all. Now let us discuss about the design thinking based real-time ECG signal filtering. See, the design thinking is of 5 stages: empathy, define, ideate, prototype and testing. See, DSP plays a vital role in terms of discrete time signal processing. There are wide number of applications including telecommunications, biomedical signal analysis. Now we can discuss about the design thinking based real-time ECG signal analysis.
Sir, as you mentioned about the design thinking concept, and the first part is empathy. So while discussing about the real-time applications in the ECG, the empathy the users, especially like the cardiologists and the nurses face, is to observe the PQ or the signals. That is the signals which is passing through the human body and which is measured through the ECG. So basically what they face is they couldn't able to observe the real diagnosis waves that is coming from out of the body due to the noise signals. So this is the major problem they are witnessing. Due to this, the panicking starts from the cardiologist, and waves aren't in the normal mode, and even we couldn't justify what is happening, what is going through in the scenarios which is taking place in the hospital. So these are the emergency situations and the problems we are witnessing in the empathy stage. So we have to talk about how we are going to reduce these noises, that is unwanted noises in the diagnosis, and make the output better from the body which we are taking, or the when we are taking from the signals we are passing through. So this is about the empathy stage. That's all, guys.
Coming to the define part, we clearly define the problem statement, how we can design a real-time ESP system that remove the noise, ECG noise, like power line interferences and baseline drifts and muscle artifacts. This uses the important signal clear, and this use the low powers for mobile use, so that this helps to us focus on the user-friendly, fast and efficient solutions.
So coming to the next part, as she mentioned, empathy is the part where we can identify, where we can come out with the problems, and define is the part where we pick out the major problem. So ideate is the part where we'll be giving the solution for that major problem. In that cases, there are some solutions to fix the ECG noises. The first one will be the filter out noise. We will be using a filter to reduce or to get out the 50 by 50 Hz voltage noise. And the next one will be break line drift. So in that case, we will be using a filter to take out the noises which is unwantedly present in that signal. The next one will be, we will be using the muzzle noise. In that cases, we will be use a filter to take only the main parts of the ECG. The next one will be the motion noise. In that, the unwanted signals, the unwanted frequency noise, everything will be taken out from that signal. The next one will be testing. So in that testing, we will be using a match lab. So from that, the testing part is over. The next one will be hardware. In that hardware, we will be using some small or low power chip to make out the final hardware failure.
By using this filter design, we are using it as your FIR filter and IAR filter. By using FIR filter, we can get it as your finite impulse response filter. In case of IAR filter, infinite response filter, to remove the unwanted noise from frequency response of the ECG signal.
So then the prototype phases identify the signal acquisition with around resolution of 50 Hz to 250 Hz to analyze the waveform to be implemented in the output waveform in DSP. In DSP, we have written the code in C and implemented in the microcontroller, and the microcontroller name as STP0452, and then we have to make out the output waveform, and then we are analyzing the waveform with the signals of filter, and at last it consists of 3 types with 50 Hz filter and band pass filter and high pass filter. Here the band pass filter is used for baseline correction, and high pass filter is used for high pass is used for error correction in the waveform. So these are the types of filter we have to talk in prototype. So these are the various points of a prototype.
So after that, the final stage is what? Testing, right? So in this phase, it is a process of iterative testing, and we are going to refine the unwanted and disadvantages from the product what we have designed. And firstly, we are going to give this product to a clinical test. There, cardiologists have given us a feedback where they have analyzed the filter design and they have appreciated as like it has more advancement than before, and the QRS wave is clearly visible, and we can also have a clarity in T wave also. And finally, it gives us additional informations, like we can update this to the next version by providing automatic detection of unwanted ups and downs in the graphs, and we can also incorporate AI into the final product. So that's all about testing phase.
As everyone said, using IR filters and FIR filters in ECG has helped to develop it from much better than it's now. So the waves are disturbed by noise in the filters can be rectified. The problem is to reduce the noise from the ECG filters. It is the empathy part, and the define part is the idea of using IR and FIR filters to implement it and reduce the noise. The idea is to use them and remove the noise completely, and we can update them in there. The prototype is using the microcontrollers and embedded system. In that makes it more technological improvement, and the testing part is the user's feedback. So this is
with the help of design thinking. Okay. Design thinking plays a vital role in real-time ECG signal processing. With the help of these filter design, we can remove the unwanted noise by implementing the newly artificial intelligence into the design thinking concept. We are removing the unwanted noise in the real-time ECG signal analysis. Thank you all.
Thank you.